back to my channel. So this video we are starting a new chapter 5, which is arithmetic progression, and this is the last chapter from algebra. If you are new to the channel, please don't forget to subscribe. So firstly we will do the chapter explanation, then later we will do the textbook solutions. So let's start. What is an arithmetic progression? An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Also, an arithmetic progression is a progression in which the difference between two consecutive terms is constant. It is also called an arithmetic sequence. So, arithmetic progression is a list of numbers where the difference between two consecutive numbers is always fixed. It's always constant. Let's see few examples. Let's see few list of numbers. Consider the below following list of numbers, which is 1, 2, 3, 4, 5, 6, 7, 8. So it is a counting number. So 1, 2, 3, 4, 5, 6, 7, 8. So here is it an arithmetic progression? Let's see. So the first number is 1 and the second number is 2. So the difference between these two numbers is 1. If we take the number and the difference between the second number and the third term is also 1. And if we take the difference between the fourth term and the third term is also 1. So here the common difference, the difference between two consecutive numbers is always same. It is constant. So we can say this is an AP. This is an arithmetic progression, and the common difference here is 1. The common difference we can denote it as D. So the common difference in the first given list of numbers is 1, and it is a pattern of numbers and it forms an arithmetic progression. Now let's see the second list of numbers, which is 100, 70, 40, 10. So let's again see the common difference between two consecutive numbers. So here the 100 to 70, so that is minus 30. 70 to 40 is again minus 30. 40 to 10 again minus 30. So here the common difference is, which is D, is equal to minus 30. Is this an AP? Yes, this is also an arithmetic progression. So this is also an AP. Why? Because the common difference between two consecutive terms is constant in here also. So that is minus 30. So the common difference is 30 and it is constant in this pattern. Can we list off two more numbers in this pattern? So that will be, next one will be minus 20 and next one will be minus 50. Correct? And it will go on. So this also forms an arithmetic progression, and with a common difference of minus 30. Now let's see the third list of numbers, which is minus 3, minus 2, minus 1, 0. So let's see the common difference between the first two terms, which is minus 3 will be plus 1, and here that will be also again 1, that will be also again 1. So what will be the next numbers in this pattern, this list sequence? So that will be, next one will be 1, 2, 3. So here we can see the common difference between two consecutive numbers is also constant. It is same, which is D is equal to 1, and this is also an arithmetic progression. Now let's see another list of numbers, which is 3, 3, 3, 3, 3. So here again next one will be 3, 3, 3. So the common difference between each term is 0 here. So the common difference between two consecutive terms in this list of numbers is 0. So we can say D is equal to 0. Whether it forms an AP? Yes. This is also a form of arithmetic progression. So this list of numbers is also a form of arithmetic progression. Now let's see the last list of numbers, which is minus 1, minus 1.5, minus 2, minus 2.5. Here the common difference is minus 0.5, 1 and 1.5. Again minus 1.5 to minus 2, that is again minus 0.5. Again here it is minus 0.5. So next one will be minus 3, minus 3.5 is, and the common difference here is minus 0.5, and this also forms an AP. This list of number is also an arithmetic progression. Now I hope you know what is an arithmetic progression and what type of patterns we can see in an arithmetic progression. So based on the common difference, it can be either negative, positive or 0. The common difference can be either positive, negative or 0. We have seen all the three in this list of numbers. So based on the common difference, we can say in how the AP will looks like. So AP can be either in an increasing pattern, or it can be on a constant pattern, or can be a decreasing pattern. So if the common difference is a positive number, so in the first example the common difference was 1, which is a positive number. So here we can see the AP is in an increasing pattern. So this was in an increasing pattern. Second one, the common difference was a negative number, was a minus 30. So here we can see the AP is in a decreasing pattern, which is 100, 70, 40, 10. So that's in a decreasing pattern. Also there was a situation where the common difference is equal to 0. Here we can say the AP is constant. So there is no increasing or decreasing pattern. It is a constant pattern. So based on the common difference, based on the common difference value, we will know whether an AP is in an increasing pattern, or it is a constant one, or it is in a decreasing pattern. Okay, and common difference is the difference between any two consecutive terms. So for an AP, the common difference between two consecutive terms should be always fixed. It is always constant. Now let's see a few arithmetic AP in our daily life. Let's see a few examples. The heights of some students of its school standing in a queue in the morning assembly are 147, 148, 149 and 150. So can we see a arithmetic progression here? The first term is 147, which is 147. The second term is 148, 149. So the common difference, which is denoted by D, the common difference between two consecutive terms is here 1. Correct? Here also it is again 1. So yes, this shows an arithmetic progression. So this is an arithmetic progression, and the common difference here is 1. Another one, the cash prize in rupees given by a school to the toppers of classes 1 to 12 are respectively 200, 250, 300, 350 and the last term is 750. The last prize given is 750. So the first term is here 200 and the second term is 250. Correct? So the difference between first and second term is 50 and the third term is again the difference is common difference is 50 and the fourth term the common difference is again 50. Now from the above given patterns arithmetic progression, we can form a standard arithmetic progression formula. We can form a standard formula for an arithmetic progression. Here we can say A is considered as the first term, where the first term equals to A and common difference is denoted by D. First term of an AP is denoted by A and common difference is denoted by D. So if that's the case, the standard form of the arithmetic progression is given by the formula A is the first term, A plus D, which is the first term plus the common difference will give you the second terms. The first term plus 2 times the common difference will give you the third term. Correct? And A plus 3D will give you the 3 times common difference will give you the fourth term. Now let's see that in a different slide. So the standard formula for a quadratic equation is A. Then second term will be A plus D. Third will be A plus 2D. A plus 3D. And A plus 4D. Let's see the previous example given here, which is 200, 250, 300, 350. So first term was 200. And the common difference was 50. Correct? The common difference was 50 here. So the second term was 200 plus 50, which is 250, and the third term was 200 plus 2 times 50, which is 300. Correct? So the fourth term was 200 plus 3 times 50, which is 350, and the fourth term was 200 plus fifth term was 4 times 50. Correct? This was the fifth term equals to 400. So this was the first term, second term, third term, fourth term and fifth term. So here we can say a standard form of a arithmetic progression is the first term is A, the second term will be A plus D, which is D is the common difference, and the third term will be A plus 2 times T, fourth term will be A plus 3 times T, and fifth term will be A plus 4 times T. First term is represented by the letter A. The first term is always represented by letter A. The last term is represented by letter L, and the common difference between two terms is represented by D, and the number of terms is represented by letter N. The number of terms in an arithmetic progression is denoted by letter N. So, another one, finite AP. So there will be finite AP and infinite AP. So finite AP is that an AP containing a finite number of numbers is called finite AP. A finite AP has a last term. So if we know the total number of terms in an AP, if it is a finite. So for example 3, 5, 7, 9, 11, 13, 15, 17, 19, 20. Here we know which is the last term. So it ends with the last term. So these type of AP are called finite AP, and there is infinite AP, which is an AP which does not have a finite number of terms is called infinite AP. Such AP do not have a last term. So here it is 5, 10, 15, 20, 25, 30, 35, 40, 45, and it is infinite. So there are finite AP and infinite AP. Now let's see few examples and find the first term and common difference. So first one here for the AP 3 by 2. The first term is 3 by 2. Second term is 1 by 2. Then again 1 by 2 minus 1 by 2. Then again minus 3 by 2. Here we need to find the first term A. So A is equal to 3 by 2. And the common difference. So common difference will be the difference between two consecutive terms. So that will be the second term is 1 by 2 minus 3 by 2. So that will be minus 2 by 2, which is minus 1. So the common difference between the first two terms is minus 1. Let's see the difference between the second term and the third term. So the third term is minus 1 by 2 minus 1 by 2 minus the second term, which is 1 by 2 is easy also minus 1 plus minus 1. So that is equals to minus 1. The second term, the difference between minus second term and third term is also minus 1. Let's see the difference between the fourth term and the third term. So that is minus 3 by 2 is the fourth term and minus 1 by 2 is the third term. So difference between that is minus 1. So that is minus 3 plus 1. So that will be minus 2 by 2. Again it is minus 1. So here we can say the common difference is D is equal to minus 1. And the first term is A, which is 3 by 2. The first term is 3 by 2. So this is an arithmetic progression. So let's see another example. Which of the following list of numbers form an AP, and if they form an AP, write the next two terms. So first we need to see whether it is an arithmetic, if this list of numbers forms an arithmetic progression. For that we need to see the common difference between two consecutive terms is always same. So the first term here is which is A is equal to 4. The common difference between first term and second term, which is 10 minus 4, so that is D equals to 6. Secondly, the common difference between third term and the second term is also 6. Again 16 and 22 is also 6. So we can say this is an AP. This forms an AP, and we are asked to write the next two terms. So what will be the next term for this in this AP? So that will be 22 plus the common difference. So that is 22 plus 6, that will give you 28. The next term will be 34. Correct? Again the common difference is 6. Let's see the next one. 1, minus 1, minus 3 and minus 5. So that is the difference between the first two terms. So that is minus 1 will give you minus 2. So the first difference between first two terms is minus 2. Let's see the difference between the second term and third term. So that is minus 3 minus minus 1 will give you minus 2. Minus 3 minus minus 1 will also give you minus 2. And the difference between the third term and fourth term is also minus 2. So this is also an AP. It formed because the common difference is constant. What will be the next term? So that will be minus 5 minus minus 2 will give you minus 7. Then again minus 9. So these are the next two terms for in the AP, and it goes on. Let's see the third example, which is minus 2. This first term is minus 2. Second term is 2. And again the third term is minus 2. Second term is 2. So let's see the difference. Common difference here is 2 minus minus 2, that is equals to 2 plus 2, which is 4. This is the difference between first and second term. Let's see the difference between second term and third term. So that is, the third term is minus 2 minus 2 minus 2, which is the second term, equals to, that will be minus 4. And what is the difference between 2 and 2? The third term and fourth term. So that is, fourth term is 2, third term is 2 minus minus 2, which is 2 plus 2, which is 4. Is this in AP arithmetic progression? No, the common difference between two numbers is not the constant. The first one we got plus 4 and the second was minus 4, and the common difference between the third and fourth number was 4. So it is not a AP because the common difference is not a constant here. Now let's see another one. What is the difference between another list of numbers? So first, the difference between 1 and 1 is, the first two numbers is 0. The difference between the second number and third number is again 0. The difference between the third number and fourth number is 1. So the common difference here is, the common difference, is it a common difference? No. So it does not form an A. This is also not an AP. So this forms not, this is not an AP. The fourth one is not an AP because not an arithmetic progression, because the common difference is not constant. Similarly, the third one is also not an AP because same, the common difference is not a constant. But the first one is a AP, and this is also an AP, arithmetic progression. Only because the common difference is constant here. I hope you understood the basic of arithmetic progression. Next video we will see to how to find the nth term of an arithmetic progression. If you are new to the channel, please don't forget to subscribe. Thank you for watching.